one, and that was the one that 90% of you made corrections to, and now almost everybody is passing. This is good. Tomorrow's quiz might change it back. I don't want that to happen. So you're going to get ready for this. The other thing that's happening tomorrow is a binder check. If somebody can turn that off, don't snooze it. Okay. Binder check tomorrow, 3-ring binder. You're going to have the unit guide in there. You're going to have graded work in there. You're going to have blank paper in there. Everybody's going to have the things. And for those of you that are prone to crying on a regular basis, put some tissues.
Okay.
Dividers, that's your choice. I think dividers are a good thing. You know, as I'm like trying to like get back to normal, right? We have internet now. Woo! Figured out the whole Wi-Fi hotspot on my phone, so at 4:30 in the morning I've got internet. I was going to go to Office Max yesterday because Office Max makes me feel good to get my colored pens and get my binder divider. It's closed. I almost cried in front of Office Max. I'm like, but my things, my preciouses are in there. There is a binder check tomorrow. Yes, thank you, Lord of Rings reference over there. Now I got something to talk to Chris about. Okay, so binder check, you need a 3-ring binder. If you don't have a 3-ring binder, please let me know. I probably have some floating around somewhere. But I'll tell the jokes here. Okay. Graded corrections are here. Daisy, just take the folder and pass the folder around. No, just take your stuff, girl.
Okay.
All right. So here's what I would do if I were you and I was studying for the quiz. Let's go through the survival guide here. Survival guide, unit guide. Unit guide. I would make sure on page 15 that you, maybe each want to put a little star next to this. I'd make sure that on page 15 you understand the limit definitions of horizontal and vertical asymptotes. So maybe you've got the unit guide, you put a little star next to this.
What page?
That was 15. I would make sure that for a problem like this one on page 16 that we did in class, I want you to know how to graph it on your calculator and find the asymptotes. But that's not calculus, that's calculator. Or calcu-now, depending on the poster. You have to, oh my god, BC students who have already taken the quiz, can I get an amen on this one? You best know how to handle a rational function like this and find the asymptotes using limits and all the things. BC students, can I get an amen on that? Can I get an amen on that? Thank you. Doesn't even matter what I said, just go with it. You want to make sure you know how to do a problem like this using limits. If you don't, it's going to go badly tomorrow. All right, other things you need to know. Other things you need to know. There's some stuff we're going to do today. Oh, yes. Continuity. On the bottom of page 25. Adrian, I'd find the bottom of page 25. I'd put a little star next to this.
Oh, wow.
Okay. Bottom of page 25. Stay with me. You don't want Angry Man to come out. He does not go back in his box easily. Okay, page 25. You need to know the 3 steps for showing a function is continuous. You need to know them well. I'm not going to ask you the Bobo question of like, is the function continuous? You're going to have to prove it. Okay. Oh. You're going to have to like show me that a function is continuous. Now I'm looking on page 27. So like, yeah, we did that. Here's a giveaway. It must be because I'm just a little tired. On the bottom of page 28, I would put 2 stars next to this one. Not only is it a piecewise function, not only do you have to figure out if the function is continuous or not, you have to figure out the just right value for k to make this work. We did this one in class, we did it carefully. I might even put 2 or 3 stars there. That's as kind as I'm going to get.
Thank you.
You're welcome. dear, for you, Jackie, anything. All right. The intermediate value theorem over here on like page 33. You best know the intermediate value theorem. You best know that we are talking about what kind of functions? Continuous. If it's not a continuous function, don't talk to me about the IVT. I'm going to get you, Jackie. 33. Okay. So I would make sure that you can do a good, solid write-up. You know how to use it. And hey, good news, that's the end. That's the end. If you are comfortable with limits, continuity, intermediate value theorem, and asymptotes, life will be good tomorrow. If you are not comfortable with that, it's going to be a miserable 30 minutes, but not for me. I'll just watch. I'll just watch. Watch and what?
Drink your tears.
Drink your tears. I might even bring in a second water bottle. Okay. Anyway, all right, so if you guys could get out your calculators. Calculators now, I forget, is this the class that likes like really hard problems or the easy problems? Good. I heard a lot of people saying I want hard problems. Good. So here we go. There really was only one acceptable answer there anyway, y'all. Okay, on page 21, there is a nasty, ugly function, and I need you to find for me all the asymptotes. It is fine right now for you to use your calculator. I'm going to take that away in 2 to 3 minutes. Henry, if you wouldn't mind modeling the work on the computer, that'd be great. Adrian, where'd you go? Here you go. Diego. Henry is back there. He's coming back. Chris. Here you go, sir. Destiny. Rolling forward.
Think about
Don't worry about Destiny's college visit. I'll take care of it, Rebecca. She'll be all right. Henry, are you graphing on the calculator back there? That's why you're back there. I mean, you were bad, but not that bad. Okay. This is meant to be the easy part where you have your calculator and you're using the calculator to find the asymptotes. Then I'm going to take the calculator away. Yeah. Absolutely. What a great question ever. Eval? Sorry, no, I taught an ever like 16 years ago.
Zero over a number?
Okay. Alright, quick show of hands. How many of you guys have a graph that looks something like this? Do we have evidence of asymptotes?
Yes.
How many horizontal?
2.
How many vertical?
1.
Okay, 2 horizontal, 1 vertical. Now, I saw some folks that said, oh, I've got an asymptote over here at 0. Oh my God, sad panda. It is not a horizontal asymptote at 0. Jackie, why?
It's, isn't it y equals 0?
Thank you. If this is a horizontal asymptote, it is a line. Now, I saw some other folks who were struggling to find this other one. Anybody figure out this one? What'd you get, Paul?
Y equals 5.
This is over here at y equals 5 in the vertical asymptote. should be over here at x equals 0. Now that is with your calculator. Your calculator is doing all the work. You're doing a little bit of exploration, but this is what we got so far. Everybody good? Jeanette?
So without the calculator, how do we know that?
Oh my God, it's like you've read my lesson plan. Thank you so much. Karina, can we get everything over here? Okay, here we go. Hope you guys have your seatbelts on. You're gonna need them. Okay. Jeanette's question was, but what if tomorrow you don't let me use my calculator? What am I supposed to do? You're supposed to use limits. So let's start the conversation with the horizontal asymptote. Or asymptotes. I want to get some hands. How would you find the horizontal asymptotes? What would you do? Sylvia? Okay, we need to find the limit as x approaches infinity of 5e to the negative x over e to the negative x minus 1. This is how we need to start. Jose, what might you do? What are you thinking about over there?
Well, I was just thinking that the 5dx and 5e to the negative x and the e to the negative x, they have the same.
Don't say cancel. Don't say cancel. Don't say cancel. They don't cancel. They don't cancel. They're never going to cancel. Never, ever, ever. They don't cancel. What else?
I was gonna say, since they're the same exponent,
Yeah.
the same degree, can't you do the shortcut?
Okay, so the shortcut that you're thinking about is if you're dealing with polynomials, things like x squared over x cubed. Not the case. They're not going to cancel. What you got?
So if like you were to plug in infinity for x,
Yeah.
it would be like 5e to the power to negative infinity. It would be approaching 0.
Oh my God, one more time, because I don't think anyone actually was listening to you at that point. A little louder, a little manly. Bring it on. What I heard you say is, as x approaches infinity, I know what the graph of e to the negative x looks like, don't we? What does it do?
It approaches 0.
As x approaches infinity, e to the negative x approaches 0. Are we okay with that? The graph of e to the negative x, a parent function that we know well, approaches 0. So what happens in the numerator? 5 times something approaching 0?
0.
0. What about the denominator? Not 0.
-1.
This guy here is approaching 0. Minus 1 is -1. Y'all, what is 0 divided by -1?
0.
0. What that means to me is that the limit as x approaches infinity is 0. Therefore, I have a horizontal asymptote at y equals 0. Way to go. You're on the board. And does the graph support that?
Yeah.
Absolutely. The graph, I look at the graph, Jesus, and I'm like, yeah, y equals 0. But you need to be able to do it with limits. Okay. Henry? Henry? Alt-tab?
He broke
Change
it.
when you type.
He broke it.
There you go. No, just one, son. Wow. Andy, you were bad, but not like this. Okay. Here's the problem. There's a second horizontal asymptote. Second horizontal asymptote happens when you look at x approaching negative infinity. So we need to look at that. You need to see what's the limit as x approaches negative infinity of 5e to the negative x over e to the negative x minus 1. Now, you guys said you wanted hard. Sheila's like, I did. Okay, so let's do it again. As x approaches negative infinity, what happens to the graph of e to the negative x? E to the negative x would approach positive infinity. So the numerator approaches infinity. The denominator? Infinity minus 1?
-1.
Infinity. Infinity over infinity
Infinity.
is another indeterminate form. It's not an answer. It doesn't tell you anything at all. It's the indeterminate form. So what you need to do is something else. And this is the part where I would not necessarily expect you guys to snap to it right away. This is just a little trickery that I want to push you with. I'm going to multiply by e to the x over e to the x. Diego, is it okay to multiply by e to the x over e to the x? Why? because it's fancy 1. Okay, now, right, the big question might be on somebody's mind, but why? Why would you ever multiply by e to the x over e to the x? Because something really nice is about to happen. Let's actually do this. Limit as x approaches negative infinity, 5 e to the negative x times e to the x. E to the negative x times e to the x. Bases are, I hear cancel, I don't like cancel. E to the negative x times e to the x, the bases are the same. Bases are the same. Add the exponents. And what you get is 5e to the 0 power. E to the negative x times e to the x, e to the negative x plus x is 0. How about the denominator? E to the power of 0 minus e to the x. Let's see if we can go a little bit better here. E to the 0 is 1, and 5 times that would have to just be 5. E to the 0 is 1. What happens as x approaches... Jackie, do you have a question or do you have an answer? Yeah.
But I told you couldn't not cancel, but make it a 1 because it was a subtraction. It's not being multiplied by the ex.
The e to the x gets distributed to both of the terms here in the denominator.
Yeah.
E to the x times e to the negative x is this e to the 0, which is 1. The e to the x times 1 is e to the x. That's okay. Let's finish this off. As x approaches negative infinity, anybody know about the graph of e to the x? Think about it. Yeah, you guys are doing the right thing. Sketch it in the air. Sketch it in the air. E to the x increases from left to right. So as x approaches negative infinity,
Yes. Approaches 0.
0. Finish off the thought. You know that as x approaches negative infinity, e to the x approaches 0. What happens over here? We get 5 over 1 minus 0, which is 5. Where's that other horizontal asymptote? Therefore, you've got a horizontal asymptote at y equals 5. Nice job. Nice job. Not easy, not trivial. I was not expecting either of those things to happen. Last thing, we need to look for vertical asymptotes. Where do those vertical asymptotes come from? I want to get some hands on this. I see Jackie, I see Paul. We've got about 21 other people I'm worried about. I see Diego. Vertical asymptotes. Talk to somebody near you. How do you find vertical asymptotes? Okay, I heard it from a whole lot of folks. We're going to set the denominator equal to 0?
Yes, sir.
Okay, set the denominator equal to 0. E to the negative x is equal to 1. If e to the negative x is equal to 1, e to what power is 1? That should be 0. That should be 0. But before you make the bonehead move and say, oh, there it is, you have to go and find the limit. You have to find the limit. If I take the limit as x approaches 0, I get 5e to the 0, which is 5. E to the 0 is 1 minus 1. We're getting 5 over 0. The top gets close to 5. The bottom gets close to 0. The whole fraction. What happens?
It's getting closer to 0.
Infinity.
If you're not sure, check on your calculator. Take a number really close to 5. 4.99999. Divide it by something really close to 0. Big, like number close to 5 divided by 0 is going to be approaching positive or negative infinity. Therefore, we have a vertical asymptote at x equals 0. Okay. What questions are out there? Karina.
So the red part, like where does that go? Like with which equation?
Like the red part here?
Yeah.
These are just like the thoughts I'm having in my head so I can figure out what this limit is.
Okay.
Because I can't plug in. Plugging in doesn't make sense. But I can say, well, what do I know about the graph? As x approaches infinity, the graph approaches 0. And so I can use that over here. Okay, Henry.
like we know that it's like asymptote with x equals 0. Like, what if you didn't know that? Like you plugged in 0.
Yep.
When doing the math, like, how would you know it's plugging 0 without actually knowing?
How would you know to find the limit as x approaches 0?
Yeah.
Without doing this? I
Oh,
wouldn't.
I see.
Right, you start you start the search by setting the denominator equal to 0 and solving it, then find the limit, because if this had come out to be some number, you'd say you have a hole, you don't have an asymptote. Okay, Andy?
How does this is from the e to negative x?
Okay, well, so we've got e to a power equals 1. Right? E to what power, Andy, would be equal to 1? 0. Okay, last question. Develop.
What's the indeterminate form? Like, how did you get that from?
Because we knew that as x approaches negative infinity, e to the negative x approaches positive infinity, you were getting infinity over infinity, which is just like 0 over 0 is the indeterminate form. Infinity over infinity is another indeterminate form.
How did you solve it? Like,
That's when this magical thing happened over here that I would not expect you guys to come up with. Great.
Would like horizontal asymptotes have like holes in it?
Horizontal asymptote. I want to think about that before I get back to you. Okay. I think we're good. I think we're good. Sheila, you okay back there? You look like you're in pain. All right, good. All right, we're going to do this awkward transition. So could you make like awkward eye contact with somebody? Imagine you're in 8th grade and it's like really awkward. Okay, awkward, really awkward. Henry, that was not awkward. That was like serial killer. Okay. Awkward transition. Okay. Second topic for today. Second topic, related to asymptotes, I promise. We're going to talk about something called growth rates. Page 22. So it's just an awkward flipping of the page one. Okay, we're still good. Okay, what we're going to talk about, these are called growth rates. Growth rates have a lot to do with asymptotes, which is why we're going to study it. It's going to help you understand how functions behave. But let's talk about growth first. I need examples of functions that grow as the x values approach infinity. So pull it up in your brain. All these parent functions that you know. Which ones are growing as x approaches infinity? Uh-oh. Yeah, now you see the lifesavers, and you're like, ooh, me! Jeanette, give me an example of a parent function that grows as you approach infinity. Y equals x. Does that grow? Okay, good. Other ones that grow. Paul. Y equals x squared grows. Go for it.
Y equals absolute value of x.
Y equals the absolute. We've got all these functions that grow. Any other ones? Jose.
Y equals x cubed.
Y equals x cubed. That one grows. Okay, what about all the quiet people in the back? Okay, what about you, my calculator thief? What you got? Y equals e to the x grows. I know other ones that grow. One of them is very natural. Chris, the natural log. Thanks for playing. That was a serious catch. Henry, any other ones that grow? Square root of x grows. Sine of x. Sine of x does not grow. It is an oscillation. Somebody was showing off for the ladies. Okay, you got another one. That's good. Okay, so here's the thing. One of the things we care about in calculus is how fast these functions grow and how do you compare them based on their growth. So what I've got for you, I don't want to tell you anything. I want to give you 2 minutes to go through and read through, let's call it 4 minutes. Page 22. On your own, there's highlighters in the middle of the table, except for this group over here. Sorry, I think Rebecca has taken them already. Take 4 minutes. Read through the notes on page 22. Thank you for asking. If it is an emergency, like you can't control your bladder, Jose Rubio, on camera, then go. Okay. Okay, one more time. This is silent reading. You're going to have questions for me. Henry, you doing all right back there? This is what it would look like in a calculus textbook. If we had such a thing. We've got about one more minute. If you're reading this and it's not making a whole lot of sense yet, then get ready to ask me some questions. Okay, so according to what you just read, when we're talking about growth rates, we're talking about comparing two different functions. Maybe their names are f and g, it doesn't really matter, okay? You're comparing two different functions. The way that we're actually going to determine which one grows faster is you're going to take the limit as x approaches infinity. Maybe now you're like, oh, I see why we're talking about this. We've been talking about limits. If I take the limit as x approaches infinity of f of x divided by g of x, and I get infinity, which one grows faster? F of x. The one on the top is the one that grows faster. If, when you take the limit as x approaches infinity of g of x over f of x, and you get 0 for your answer, which one grows faster? The denominator grows faster. If you take the limit as x approaches infinity of f of x over g of x and you get some number, you get 5, you get 12, you get negative 19, your answer?
It's the same.
They grow at the same rate. Okay? So let's look at a sample calculation and let's look at the conclusion here. So the question might be this. Here are these two functions. I've got the function f of x is equal to 100x squared plus x. I've got the function g of x, which is x cubed plus 1. I want to figure out which one grows faster. This first one, degree 2, so this is a quadratic. The second one, g of x, is degree 3. This is a cubic. You probably already know from Algebra 2, or maybe you kind of have some good instincts from pre-calculus here, which one's going to grow faster?
Quadratic.
We've got degree 2, we've got degree 3. Generally speaking, the bigger the degree, the faster it grows. The faster it increases towards infinity. The way that you would prove it, Chris, is you'd actually say, let me find this limit as x approaches infinity of the f of x divided by g of x. Let me go through, and like here I'm multiplying by 1 over x cubed over 1 over x cubed. Is that legal? Is that legal? Why is that legal?
Because it's so fancy.
It's a fancy one. Okay? And if I multiply everything through by 1 over x cubed, that's what I'm going to get. I'm going to simplify. As x approaches infinity, 100 over x goes to 0. My final answer is 0. 0 isn't your answer. 0 isn't the end of the story. This tells me that the limit as x approaches infinity of f of x over g of x is 0. Which one grows faster? Uh-oh. Which one grows faster? Go back to the notes at the top here. G of x, the denominator, grows faster. So we can conclude g of x grows faster than f of x does. And that would be the conclusion that I would want to see. Hold on, Diego. The way we're going to figure out growth rates is we look at the two functions, we form a ratio, and we take the limit as x approaches infinity. If the answer is 0, the bottom grows faster. If that limit is infinity, the top grows faster. And if you get some number like 5, 2/3, they grow at the same rate. Somebody had a question and I ignored you for a second. Diego, did you have a question?
Oh.
Karina.
On the last problem, I noticed you put e of x, like the same thing on the bottom, while on this one you put like the opposite. Like.
Whichever one you put in the denominator, if your limit is 0, then the denominator goes faster. Alright, so here's what I want you guys to do. I want you to show me what you can do. Here we go. I'm going to give you a whole bunch of functions. There's 9 different pairs of functions. Every single group is going to do pairs 1, 2, 3, and 4. Everybody gets pair 1, 2, 3, and 4. If you need to use your calculator, feel free. What I want to see, I want to see you're finding limit as x approaches infinity, x to the 4th plus 2x over x to the 8th. What's that limit? X to the 4th plus 2x over x to the 8th.
0.
That limit is going to be 0. What's the conclusion?
G of x.
So this would mean that g of x grows faster. Pretty good? I want you to do 1, 2, 3, and 4. And now here comes some bonus stuff. Chris's team, you guys are going to do 5 and 8. Andy's team, 6 and 9. You're going to have to remember, because I want Daisy's team, 7 and 9. Rebecca's team, 5 and 8. Jaggy, 6 and 9. Yvel, 7 and 5. Yeah.
I know, I'm talking about how to just say this is going to equal because the only thing you guys do is make this bigger.
Oh, wait, for one, I mean, for so when it equals L.
One of them on top, one of them on the bottom. Doesn't matter. Not because you're cold.
That will equal bigger number.
Well, the thing is, like, you could do it either way. Yeah, because if you put it right here, like, if you put it this on the top and then this on the
Show it to me and I'll let it try.
You're right.
Hold on. Make sure you're showing me that limit as x approaches infinity. Okay. It may seem like it's not important, but it's
I I think you go in order. Like,
Exactly. What number are you going to get?
Like, how do we determine which one?
That actually doesn't matter.
But like, it should be the degrees.
Well, what I'm saying is, if I put x to the 8th in the numerator and the x to the 4th in the denominator, what's your limit answer? Not 0. If you put x to the 8th in the numerator and the x to the 4th in the denominator, you're going to get infinity. And then you're going to say it's the top that grows faster. Okay? It all... Right. Friends? It doesn't matter. All right. If I can flip it together. I think for the most part, 1, 2, 3, and 4 are going okay. One of the common questions I hear coming up is, but which one do you put in the top? Right? Which one's in the numerator? Which one's in the denominator? Usually, I put whatever one they mentioned first in the numerator, and I put the other one in the denominator. But here's the thing. What's this limit? Limit as x approaches infinity, x to the 4th plus 2x over x squared. Not 0.
Infinity?
It's going to be infinity. So what's the conclusion? F of x grows faster. What if you're that strange kid that says limit as x approaches infinity of x squared over x to the 4th plus 2x. For this strange teenager, their limit answer is going to be 0. But their conclusion, their limit is 0. Which one grows faster? The denominator, which is still f of x. Okay. What I'm looking for in all of these is your limit comparison, your answer, and your conclusion. That's what I'm looking for. Okay? So number 3, what I want to see is limit as x approaches infinity of x to the 4th plus 2x, 3x to the 4th minus 2x. Gosh, what's the limit answer here?
L.
It's going to be 1/3, right? What's the conclusion?
They grow at the same rate.
They grow at the same rate. F of x and j of x, f of x and j of x grow at the same rate. What is going on with the handwriting? How do you get 1/3? Somebody help Andy out. How do we get 1/3? Where'd that come from? Marilyn, where'd 1/3 come from?
You look at, since they have both have the same degree,
Both have the same degree.
then you take the coefficient,
You look at the coefficients.
so it's 1/3.
1/3. Because the degrees are the same. If they weren't the same, we wouldn't do it this way. Sylvia.
Let's say the degrees are still the same, but they both say, one says plus 2x and the other one says negative 2x. What if those are different?
So here's the thing. Degree means what is the largest exponent. The largest exponent. So 1x to the 4th plus 2x, I determine the degree by looking at the 4. I don't care what else is here. Meaning, what if I made this 2x squared? What's the degree? Still 4. 2x cubed? Degree 4. 2x to the 5th? Degree 5. The degree is about which one is the biggest, not which one is first. All the friends are good? Yes, sir.
So if they grow at the same rate, would the number, the L number,
Yep.
would technically be as if you were finding the horizontal asymptote?
It's a lot, there's a connection here with horizontal asymptotes for sure. For sure. Alright. So, limit. I wanna move you guys on here. Limit as x approaches infinity. X squared over the square root of x. Limit as x approaches infinity. X squared over the square root of x.
Infinity?
This should be
Infinity?
infinity. The conclusion? H of x grows faster. Alright. Now, I just want to give you guys a little bit of a nudge. Limit as x approaches infinity, x to the 8th over e to the x. Okay, this is the one I just want to give you guys a little bit of a nudge. I do not expect anybody yet to be able to look at that and know what the limit is. But I think you have a tool that might be helpful in figuring out the limit as x approaches infinity of x to the 8th over e to the x. What could we do? Talk to somebody near you. What could you do to figure out this limit as x approaches infinity? If you had access to all the tools possible. Andy, what do you want to do? How would you use the calculator? Okay, Andy knows she wants to use the calculator, but she's not really sure how she's going to use the calculator. Jesus, can you help her out? Graph what? You're going to graph this x to the 8th over e to the x. And the way that you're going to find the limit as x approaches infinity, Jesus, what are you going to do? You could do graph trace and plug in values. You could build a table of values and explore that way. With that, finish off whatever two I assigned to you guys. Jeanette. You could graph them separately and see which one gets up there faster. You could do that too. Lots of options. Try it out. Yes, ma'am. And then I'm going to come back over here.
How should we do this like this without the calculator?
Without the calculator is not the goal for right now. Yes, ma'am. Right. When it's a polynomial and a polynomial, like all the ones that we did, when you just look at the degree, and the bigger the degree. So the answer, that's a really good question.
Like I can never do.
So you're saying like the 0 or the infinity or the 1/3, it's telling you which one grows faster. If your limit answer is 0, it is because the denominator grows faster. If your limit answer is infinity, it's because the top grows faster. If your limit answer is a number that's not 0, then they grow at the same rate. They're both kind of going up just as fast. This is what we're going with. Definitely want to take out your calculator for this. I don't expect you to just know.
If the bottom is greater than the top, it's 0. If the top is greater than the top, if they're both equal to the number,
That's only if they have the same power.
oh, dude, that's it.
You're right. So
Well,
because this is what we're trying to find the limit of that new function, the ratio x to the 8 over here to the x. You want to graph that.
I think number 7 is going to be infinity. And y'all agree?
We're going to get there real soon.
I guess 3x is greater than x.
yeah, and 0.
Okay.
Then that means the end of x is faster.
And then
So what is it that's changing the total graph?
Okay, about 1 more minute to come up with your conclusions. So one is limit is x approaches. Oh, you're asking such a question.
Wait, I didn't have to.
Oh, you want an answer?
Yeah.
In a minute.
3x is greater than
Okay.
but you got 3x.
Alrighty, friends. Let's pull it together. Where are the groups that had pair 5? Okay. Okay. Limit as x approaches infinity, x to the 8th over e to the x. What do you have, Gonzalo?
Yeah, I have different answers in my group, but
Okay, what does your group have?
they have x to the power of e.
Wait, what's their limit answer, first of all?
Oh, they have infinity.
They have infinity. Friends back here?
Infinity.
Infinity. The limit as x approaches infinity of x to the 8th over e to the x is not infinity. It's 0. Now, for everybody in the room, which one grows fastest? E to the x, right? L of x equals e to the x.
Yes.
Equals e to the x grows faster. Okay. Pair 6. Who had pair 6? There's 2 groups of pair 6. Don't hide on me. Ladies in the back and the ladies up front. Okay. Limit as x approaches infinity. Natural log of x over the square root of x. Jeanette's team, what did you guys have?
We have the limit of x approaches infinity is 0, and then m of x is
Okay. They say the limit as x approaches infinity, natural log of x over the square root of x is 0. I agree. Based on this being 0, what's everyone going to conclude? So k of x, which equals the square root of x, grows faster. Good. Pair 7, there's 2 groups. Limit as x approaches infinity, e to the x over e to the 3x. We've got Jose's team. Where's the other group? Don't hide on me. Daisy, what did you guys get for your limits?
0.
0. The conclusion?
That n of x grows faster.
N of x, which equals e to the 3x, grows faster. Good. Hold on. Pair 8, e to the x compared to 3 to the x. Who had those? This team over here. There were 2 teams. Oh. All right, Gonzalo, what'd you get?
I got limit of x approaches infinity. So which from 10 power x equals 0.
Okay, I agree. E to the x divided by 3 to the x. If I take the limit as x approaches infinity, I get 0. Conclusion? E to the x grows faster? P of x equals 3 to the x grows faster. All right, pair 9, limit as x approaches infinity, e to the 3x over 3 to the x. What do you have for me, Marilyn? Is going to be infinity. The conclusion?
N of x grows faster.
N of x grows faster. N of x grows faster. I agree. We got 3 minutes left. Diego, what was your really important question that you asked just a minute ago? Diego's question, should he tonight he go through and memorize all of these comparisons? No, because there's something deeper that I want you to find here. There is a pattern. There is something happening here. I'm not going to tell you yet what it is, but look at all these comparisons. Can you find for me the slowest growing function of them all? Look at the list. Which one grows slowest of all? And then let's make a list from there. From slow-mo up to speed racer. Which one grows slowest of them all, Jeanette?
E to the x.
E to the x grows slowest? I disagree. I disagree. Henry? Oh wait, hold on. Stay with my question. Which one grows slowest of them all? Look at these pairs. Look at these pairs. Andy, do you see one that grows slowest of all?
Is it the one with the number?
The one that came up with the number, the 1/3?
Yeah.
Well, those guys grow at the same rate. I used all the same functions again and again and again. There's one that grows slowest of all. Square root of x is not the one that grows slowest of them all.
L of x.
One more time, Marilyn. Okay, Karina, can you move the camera?
Yes.
We're going from slowest to fastest. The slowest growing one is the natural log of x. After that, which one?
Square root of x.
The square root of x. After that,
X squared.
I heard x to the 4th. I disagree. I disagree.
X squared.
E squared.
Nope.
X squared.
X squared grows. Natural log of x is the slowest growing one. square root of x. After that, x squared. Then,
X to the power.
x cubed if it was in the list. Then x to the 4th. Then x to the 8th. Then it was e to the x. Then it was 3 to the x. The log grows slowest of all. All these guys here are polynomials. They grow with their, based on their degree. And these guys here are exponentials. The exponentials always grow fastest of all. The bigger the base, the faster the growth. The natural log is the slow-mo group, followed by polynomials, ending with the exponentials. I'll see you guys later.